The practical applications of number series and sequences. Number series and sequences are very common in practice. We can find them everywhere, from banking to construction, from physics to engineering and so on. Let's consider a couple of examples, one from each type of series discussed earlier. Let's begin with an example involving arithmetic series. Example 1. Lisa bought a $12,000 car, including interests, from a car dealer shop. She pays for the car by making monthly payments that form an arithmetic sequence. The first payment is $250 and the debt is entirely repaid in 16 installments, with a total interest of 10%. Calculate A, the amount of the last installment to be paid. B, the increase in payment Lisa has to pay in respect to the previous installment. C, the amount of the 10th installment. Solution 1. A. First, let's calculate the whole amount to be paid, which corresponds to the sum Sn of the arithmetic series obtained with the given numbers. Thus, since the total interest is 10%, a value that corresponds to 10/100 of $12,000 equals $1,200, the total amount Lisa has to pay, in USD, we have the following shown on screen. From the Gauss formula for the arithmetic series, we have the following shown on screen. Thus, given that x1 is equal to 250, n equals 16 and n equals 13,200, we obtain for the last installment xn, we have the following shown on screen. Therefore, Lisa has to pay $1,400 for her last installment. B. To find the increase in the payment means to find the common difference d of the corresponding arithmetic series, where x1 is equal to 250, xn equals 1,400 and n equals 16. Thus, we have the following shown on screen. Therefore, the installments increase by $71.875 every time. C. To find the amount of the 10th installment means finding x10 in the corresponding sequence, n equals 10. Thus, we have the following shown on screen. We obtain after substituting the known values, we have the following shown on screen. Therefore, Lisa has to pay $696.875 for her 10th installment. Now, let's see another practical example, but this time with geometric series. Example 2. Alex is a high school student. To make him more engaged in lessons, his father has promised to add an extra 20% to the monthly pocket money he gives to Alex for every 90+ points Alex scores in exams. The standard amount of monthly pocket money Alex received from his father before this agreement was $20. Calculate A. The monthly pocket money Alex receives from his father if he scores 90+ points in 13 exams in that month. B. The amount of money Alex receives in the last month if he increases his 90+ score by 2 exams every month, during the entire academic year, 9 months, given that in the first month he has scored 90+ in 3 exams. Solution 2. A. This is an example of a geometric sequence and series, with a common ratio r equals 1.2 giving that the amount increases by 20% every time Alex scores 90+ point in an exam. 100% plus 20% equals 120% equals 120 over 100 is equal to 1.2. For the general term of this sequence, we have the following shown on screen. Where x1 equals 200 and r equals 1.2. This formula is valid for 1 month only, as the values reset each month. Thus, for the monthly general term for this specific case, we have the following shown on screen. Thus, if Alex scores 90+ points in 13 exams in a certain month, n equals 13, we have the following shown on screen. in that month. B. The number of exams Alex scores 90+ points forms an arithmetic sequence, where the first term is y, 1 is equal to 3 and the common difference is d equals 2. Thus, given that the agreement is valid for an entire academic year which lasts 9 months, n equals 9, we obtain for the last term of this sequence that corresponds to the number of 90+ scores Alex obtains in the last month. We have the following shown on screen. This number corresponds to the value of n in the geometric sequence that gives the monthly pocket money Alex receives. Hence, in the last month he will receive, we have the following shown on screen. That is all for lesson 12.2.7, and the end of tutorial 12.2. To continue this chapter, please watch 12.3, Introduction to Binomial Expansion and Coefficients. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.